The purpose of this video is to give a brief introduction to a SPICE tool, specifically beige-bag SPICE. SPICE programs are a class of programs that can simulate circuits. Most SPICE programs also have a graphical interface that allows us to draw schematics. beige-bag SPICE is one such program. In this introductory video, you'll learn how to draw a basic schematic into a DC simulation. The handout corresponding to this video can be found in D2L or on the instructor's webpage. To begin, we need to open B2 SPICE. This is done by going to the Start menu under All Programs and selecting B2 SPICE AD version 5. Under this menu item, click on B2 SPICE version 5. If you're at a streaming video location, you'll need to log into the VMware client in order to find this menu item. Once you've started the program, you'll see a grid. This is the schematic background. The schematic that we're going to construct consists of a DC voltage supply, 2 resistors, and a current source. The schematic is on the second page of the SPICE handout. To add parts to the schematic, we have several options. On the left-hand side of the screen, we have an Add Parts tab. This will allow us to see all the parts that are in this program's library. Additionally, on the top, there's a Common Parts menu item. This will allow us to access some of the most frequently used parts. If we click on the Common Parts item, you also see that there are a variety of shortcut keys that can be used to place the most common of the parts. For instructional purposes in this video, we'll add parts in all 3 ways to the schematic. So let's begin by adding the 24-volt voltage supply. We'll do this under the Add Part tab. We'll go to the Virtual Components, Voltage Sources, and click on Battery. This puts the part attached to our cursor, and we can place it in the schematic simply by left-clicking. The reference designator and the value that are attached can be moved by clicking and dragging. Now, the value we want for this voltage source is 24 volts. We can modify that value simply by clicking into the part, double-clicking, and under value entering 24 volts. We could also just have clicked onto the value and that would have changed it. Once you've clicked OK, you're ready to add the next part. I'm going to add the current source next. I'll do this by going to the Common Parts menu and clicking on Current Source. We see that the current source comes in oriented to the right. In the schematic, however, the current source is oriented pointing up. To change this, we can right-click with the mouse, and this will reorient the part so that we can have it aligned as we wish. So then once we place the part by left-clicking, we can go in and edit the value. This is to be a 2 amp source. So if we double click on the part, enter 2 in for the value, and click OK, we have a 2 amp source. Now if we click on the Common Parts menu, we see that there are a variety of shortcut keys, as I mentioned before, and resistors are a very common part, and those can be placed or selected just by typing F4. So I clicked on the menu item there, and that brought in a resistor. I will place this one on the schematic, and I'll bring another one in by hitting F4, and this one is oriented sideways and we want it oriented up and down, so I will right click until it's oriented up and down and then left click. Now for aesthetic purposes, when we're placing parts on a schematic, we shouldn't put them too close to each other or too far apart. A rule of thumb I tend to use is when I place a part, I go up 2 grid points and to the right 2 grid points from the previously placed part. That gives us a decent amount of space between the parts and gives us, without creating too much space. R1's value is to be 3 ohms. If I double click into R1, I can get up that resistance value, and R2's value is to be 6 ohms. I double click into there and I have that value. The last necessary part we need to place in the schematic before wiring is the ground. Ground is necessary in every circuit. This provides a reference point for the simulator, just like the reference node that we use when doing node voltage analysis. I'm going to bring the ground in by pressing F3, since it is a very common part. Now, wiring can be accomplished by clicking on the toolbar item for wiring or by pressing the letter W on the keyboard. Once the wiring tool is selected, simply click on the green parts connector and draw a line to the desired part, double-clicking where we want that line to end. Begin a new wire by clicking on the next component to be connected and double-click on the endpoint. Continue this process until all the parts are connected as desired. Exiting wiring mode can be accomplished by clicking on the arrow key in the toolbar. Now that our schematic is drawn and all the component values are correct, the circuit's ready for simulation. For this circuit, all we're going to find is a DC bias point. To begin, we'll click on the Test tab over on the left-hand side of the screen. Once we have clicked on that, we're just doing a basic DC bias point. And once this is selected, we can go down and click on Run Enabled Tests. And we see we get a table that has all of the values for this particular circuit. Another thing we can do with a simulated circuit is to go in and in the toolbar here, we see that we can click on voltage. We'll get a dialog that I'm going to ignore. Current and power. I'm only going to do two of them because otherwise the schematic gets a little too busy. And I'll rerun the tests. And once I do that, you see it brings in the voltages and currents corresponding to different points in the circuit. So now the voltages and currents corresponding to the different nodes and components are listed on the schematic, and our job here is done. So once you're comfortable with the process for creating a schematic and doing a DC analysis, you're ready to move on to more complicated circuits and simulations. The next video will show you how to include a dependent source in your schematic.